Hi, the section 4.5, the matched case control studies. So the data are slightly different from the data for logistic regression. So we have to develop slightly different model. So consider study design. Study design means how to collect data, in which there are several subgroups, and there are one case and some controls in each subgroup. So for example, so the one observation have y is equal to 1, and the two observations have the y is equal to 0. So typically, such a study design is adapted when we will set the same condition within each subgroup. So basically, we want to control some variables. So for example, we want to see the effects of the weight and the daily calorie intake for the certain disease. But suppose that we know that the age is the primary factor for the disease. So we want to collect the data so that we can exclude the effects of age. So one possible scheme is to collect maybe the one malignant individual and the two benign individual from the same age group. At age 20, we have the 3 observations. So 2 of the observations are benign and 1 is malignant. So such sample that we will take. And the same for the second group with the age 21 up to the age 80. So in total, that we have 61 groups, and then we have 3 observations. So the total sample size is the 61 times 3, so 183 individuals. So in this way, that we can exclude the effect of age on disease. So we can compare with the same age between 2 groups. Okay, so now the model. So we have subgroups. So we have the 2 indices. So let J be the index for the subgroups. So in the previous example, the J is equal to the 20 years old to 80 years old. So we have the 61 groups. So J is 1 to 61. And I be the index for individuals within subgroups. And here, the I is equal to 0 is the case. So I is equal, so in the previous example, we have 3 observations. So I is equal to 0 is the case, and I is equal to 1 and 2 are for control. Okay, then what's the model? The model is the logarithm of the probability that one observation, the ij's observation is malignant, is equal to alpha j plus the beta transpose xij. So xij, so okay, so the pair of ij represents just one individual. So this xij is a predictor vector. So that we have actually the xij1 to xij p. So we have a predictor. So we have the parameter vector beta. So beta is beta1 to beta p. So beta transposed is the beta1 to beta p as a row vector. And alpha j is just one constant, and it depends on j. So this is the model. So you can see that the probability depends on the observation, the predictor xij. And the pj, so basically this function only depends on j. So alpha j plus the beta transpose xij. So the parameter that depends on j, but of course the does not depend on I. So I is just the individual. So parameter should be something in common. So the parameter depends on j, alpha j depends on j, but the beta, actually the beta does not depend on j. So only the j part is alpha j. So this is the model. So alpha j actually represents the subgroups, the characteristic. For example, the higher age, that we have the higher occurrence of the disease, then alpha j is higher for higher age groups. But the beta only depends on, I mean, the data does not depend on j. So for all ages, the effect of other factors, such as the daily calorie intake and weight. So the effects of these variables are assumed to be the same for all age groups. Yeah, in the textbook, in the textbook, this logarithm was stated as the logit, but that is not correct. So this is a different model from the logistic regression model. So slightly the different specification. Okay, so now that we want to think about the likelihood of this model, but actually this is the little bit different from logistic regression model. So I would like to have one concrete example to see the concept. So the likelihood function is calculated based on the assumption of matched control study. So it's different from the logistic regression. So for example, suppose that the previous model, basically the log of the pj is equal to alpha j plus beta transpose x. So that gives the malignant probabilities for one case and the two controls. And then suppose that the numbers are 90% and 70% and 60%. So the first observation, the case has actually the 90% the fitted probability for a given parameter. And the second observation, I is equal to 1. So then that is actually a control. So y is equal to 0, but the probability of malignancy is 0.7. And the third one, 0.6. So suppose that. But actually, this is one subgroup, and we know that only one observation is the case. So actually, to calculate the likelihood, we will use the conditional probability for this. So given the assumption that the only one of these three observations is malignant, that we have to calculate the conditional probability. So we have to make the summation of these three numbers equal to 1. So we divide the original number by the sum of these numbers to make summation equal to 1. So with this, actually the likelihood of this set of three observations, that this subgroup is equal to 0.409. And and we have several subgroups. We have 61 subgroups in the previous example. So we have to multiply the 61 numbers. So that is the likelihood of this model. So it's different from logistic regression. So in logistic regression, if we have 183 individuals, we have to multiply 183 probabilities. But here, the probability, I mean, likelihood is given for each subgroup. So it's a different model. And okay, so to just write down the likelihood, that we do some simplification. So we have defined the pj, p sub j of xij is equal to this quantity. And okay, so just plug in I is equal to 1, then this becomes this. And this is exponential function. So this alpha j and this alpha j cancels. So we can say that this is exponential the beta transposed xij divided by exponential beta transposed x0j. Actually, this can be written by using just one exponential. So this part minus this part. But anyway, so we leave it as is, just that we want to see the ratio. Then what's the conditional probability? To be exact, the conditional probability of zeroth observation is malignant, given only one observation is malignant. Then we do the same calculation as the previous example. So this is the probability, the unconditional probability that the 0j is malignant. Then the denominator is the summation of all probabilities. So since we are given the ratio of the pjxij and the pjx0j, the proportion is calculated as this. Yeah. So basically, this is the likelihood. So we have to multiply this from j is equal to 1 to n. N is the number of groups. Then we can get the likelihood. And we have, okay, so we have a small typo. So with the some simplification, so we divide the numerator and the denominator by this exponential of beta transpose x0j. Then we have this likelihood function. So it's just slightly simplified, because now that we only, anyway, so it's slightly modified. And so this is a function of beta, so we have to maximize this function with respect to beta. So that is the estimation method. Yeah. So this is the basic theory for the estimation for matched case control studies.